Welcome back, everyone. Today we're continuing our series on recycling old, forgotten phone chargers. No need to waste time, let's roll up our sleeves and get started. First, I'll open up the charger and remove the circuit board inside. When prying open the charger, I'll use just enough force, since the internal clips are fairly fragile. After carefully removing the circuit board, I'll add 2 solder points to make the connections easier later on. This single wire gives me a bit more reach, making the connection much easier to work with. Once that step is done, I'll drill 2 small holes in the charger cover, just enough to feed the 2 wires through. I'm sure many of you are wondering about soldering techniques, especially if you're new to DIY work. In reality, soldering isn't as difficult as it might seem at first. What really matters is understanding the basics and keeping your movements clean and controlled. With a bit of practice, it quickly becomes straightforward and surprisingly enjoyable. I'm sure many of you will be surprised by this, but AA batteries actually make a very practical choice for signal reception. They're compact, provide stable power, and are easy to find almost anywhere. More importantly, AA batteries allow for flexible testing and quick adjustments without relying on overly complex components. The antenna base is an essential part of this build. It not only provides a solid connection to the antenna itself, but also serves as the interface for the coaxial cable that carries the signal. This is a coaxial cable, a type of cable commonly used for signal transmission thanks to its stability and resistance to external interference. Its layered structure helps carry signals over longer distances while maintaining consistent quality. At this stage, I'm connecting one end of the cable to the power socket as part of the overall setup. For the other end of the coaxial cable, I'll add a straight F connector and a 90-degree F connector, making it much easier to hook everything up to the TV. Following the proper order, I'll install the straight F connector first, then add the 90-degree F connector afterward. Alright, that's everything wrapped up. Now I'll take this setup out for a real-world test to see how it actually performs. This is the most important step because no matter how good things look on paper, the final answer always comes from hands-on testing. Before connecting the device to the TV, I want to check the TV first so everyone can see that this video is not staged or prearranged in any way. Once that's clear, I'll go ahead and make the connection. It only takes a few seconds to lock onto the TV signal and settle in. That said, to know whether it's truly stable over time, we'll need to keep an eye on it a bit longer. After monitoring it for a while, I still haven't noticed any negative signs. The signal remains stable with no dropouts or flickering. To be absolutely sure, I decided to unplug the connection and hook it back up again, just to see how the system behaves when reconnecting from scratch. So that wraps up the entire process from assembly to real-world testing. From the initial connection and signal monitoring to unplugging and reconnecting, the device continues to perform steadily, with a consistent and reliable signal. This clearly shows that the result isn't based on luck or any kind of prearranged setup, but on a method that actually works. Through this small project, I want to highlight one thing. Parts that seem useless at first glance can still be surprisingly valuable when used the right way. It's not about building something overly complicated, but about understanding the basics and testing things properly. I hope this video gave you a fresh perspective and a practical idea to try out on your own. I'll see you again in the next DIY project.